Okay, one more thing to talk about in this section. If you're given a function where instead of being y is a function of x, x is a function of y, you do this exactly the same way. The only difference is when you calculate your ds, you use a slightly different formula. Notice this is dx dy squared, and there's a dy on the end. And your endpoints here go from one y value to another. And if you want to derive this, you can derive it exactly the same way that we did before. But remember, there's one part where we multiply by dx over dx, and then we move the lower dx inside. If you want to derive this, you go back to that same step, and instead of putting dx over dx, you put in dy over dy, and it gives you the exact same thing. So let's use it for this. Set up an integral for the length of the half ellipse shown here, and evaluate it using a calculator. All right, so this is our x. So that's x. So if we take the derivative with respect to y, it's going to be dx dy. And let's see. Actually, I'm going to write this out. This is 1 minus 4y squared to the 1/2. So the derivative is going to be 1/2 times this to the negative 1/2 times the derivative of what's inside. So times negative 8y. So let's see, what is that? The 8 and the 2 cancel and leave you with a 4. There's a y on top. This negative is still there. And then the 1 minus 4y squared goes on the bottom like that. So that's dx dy. Okay, now we've got to square it. Well, let's just go ahead and write out what ds is. ds is going to be the square root of 1 plus this thing squared. So when you square that on top, you get 16y squared. Of course, the negative goes away. And on bottom, you get 1 minus 4y squared. Now, we could combine that into a single thing, into a single fraction underneath the radical. But let's don't. Let's just write the answer. So the arc length is going to be the integral of this all right, from, this didn't tell us what these values are. We've got to figure out what those two values are for this one. How do we do that? Well, we're trying to solve for the y value where x is 0. So let's see, we've got x, we've got 0 equals square root of 1 minus 4y squared. Yeah. So to solve that out, you get square both sides. So you get 1 equals 4y squared. So y squared is 1/4. So y is plus or minus a half. Let's go back up there and look at that. Does that look reasonable? Yeah, I'm thinking this is zoomed in pretty well on Desmos. Yeah, so 1, 2, 3, 4, 5. So yeah, 1, 2, 3. Yeah, so that is plus or minus 1/2. So that is our answer as far as the setup goes. And to come up with the actual number for this, let's put that integral in and see what we get. Let's see, integral from negative 1/2 to 1/2 square root of, tell you what, I'm going to make this big, square root of 1 plus 16y squared over 1 minus 4y squared dy gives us 2.422 1, 1. So 2, so a little less than 2.5. And if we wanted to, we could come up here and do some rough approximations and see if that looks reasonable. But I don't want to do that. I'm going to trust this because we did it right. So that's it. And that's the last example.